Hello and welcome. In this video, we're diving into the world of Python Lambda functions. Lambda functions are small, anonymous functions defined using the Lambda keyword. They can take any number of arguments but can only have one expression. Lambda functions are perfect for simple operations where defining a full function using the def keyword is unnecessary. Let's look at a quick code example. First, we define a regular function called square, which takes x as an argument and returns x times x. Next, we have an equivalent lambda function assigned to the variable square lambda. This lambda function also takes x as an argument and returns x times x. Finally, we use the lambda function by calling square lambda with the argument 5. The result is 25. Now let's explore the syntax of lambda functions. The basic syntax is lambda arguments : expression. You start with the keyword lambda, followed by the arguments you want to pass to the function, then a colon, and finally the expression that the function will evaluate and return. Here are a couple of examples. In the first example, we have a single argument lambda function called double, which takes x as an argument and returns x multiplied by 2. When we call the function with the argument 5, it will print 10. In the second example, we have a multiple arguments lambda function called add, which takes x and y as arguments and returns x plus y. We also have a lambda function called compare, which takes x and y and returns x greater than y. Using the functions, when we call add with arguments 3 and 4, it prints 7. And when we call compare with 5 and 3, it prints true. Let's compare lambda functions with regular functions defined using the def keyword. On one hand, we have a regular function that calculates the square of a number. You start by defining a function called calculateSquare using the def keyword, which takes x as an argument. Inside the function, you calculate x times x and store it in a variable named result, then you return the result. The code shows how to use this function to calculate squares of numbers. On the other hand, a lambda function can perform the same square calculation in a more concise manner. Here, we assign a lambda function to the variable calculateSquare, which takes x and returns x multiplied by x. The example shows how to use this lambda function with the map function to calculate a list of squares. Key features of regular functions include multi-line code blocks with docstrings, can contain multiple expressions, and are reusable with a defined name. Key features of lambda functions include concise single expression syntax, can be defined in line where needed, and works well with functional tools like map, filter, and reduce. Lambda functions are especially useful when combined with higher order functions like map. The map function applies a given function to each item in an iterable and returns a map object, which is an iterator. The syntax is map with the arguments function and iterable. Here are a couple of examples. The first example shows how to convert temperatures from Celsius to Fahrenheit using map and a lambda function. Here we have a list of Celsius temperatures. We use the map function with a lambda function that converts Celsius to Fahrenheit. The result is a list of Fahrenheit temperatures. The second example shows how to apply a function to each string in the list. Here we have a list of names. We use the map function with a lambda function that capitalizes each name. The result is a list of capitalized names. Another common use case for lambda functions is with the filter function. The filter function constructs an iterator from elements of an iterable that return true when passed to a function. The syntax is filter with the arguments function and iterable. Here are a couple of examples. The first example demonstrates how to filter even numbers from a list of numbers. We have a list of numbers from 1 to 10. We use the filter function with a lambda function that checks if a number is even. The result is a list of even numbers. The second example demonstrates how to filter words from a list of strings based on their length. We have a list of words. We use the filter function with the lambda function that checks if a word is longer than 5 characters. The result is a list of words longer than 5 characters. Lambda functions can also be used with the reduce function to apply a function cumulatively to the items of an iterable. The reduce function is available in the functools module. The syntax is reduce, with the arguments function, iterable, and optionally an initializer. Here are a couple of examples. The first example shows how to find the product of a list. We import reduce from the functools module. We have a list of numbers from 1 to 5. We calculate the product of all numbers using the reduce function with the lambda function that multiplies x and y. The second example demonstrates how to find the maximum value in a list. We have a list of values. We find the maximum value using reduce with a lambda function that returns if a is greater than b, otherwise it returns b. The slide also shows how reduce works with the example 1, 2, 3, 4, 5. First, 1 times 2 equals 2. Next, 2 times 3 equals 6. Then 6 times 4 equals 24. Finally, 24 times 5 equals 120. The result is 120. The sorted function is used with lambda functions for custom sorting with a key function. The sorted function returns a new sorted list from the items in an iterable. The syntax is sorted, with the arguments iterable, key, which defaults to none, and reverse, which defaults to false. Here are a couple of examples. The first example demonstrates how to sort a list of strings by length. Here we have a list of words. We sort the words by length using the sorted function with a lambda function that returns the length of the string. The second example demonstrates how to sort a list of tuples by the second element in each tuple. We have a list of pairs. We sort the pairs by the second element using the sorted function with a lambda function that returns the second element. As the slide shows, the original words were Python, Lambda, function, and sort. Sorted by length, the result is sort, Python, Lambda, and function, where for letters leads to 6 letters, leads to 6 letters, leads to 8 letters. Original pairs are 1, 5, 3, 2, 5, 8, and 7, 1. Sorted by second element, the result is 7, 1, 3, 2, 1, 5, and 5, 8, where 1 leads to 2 leads to 5 leads to 8. Lambda functions can also be used within list comprehensions to create concise and expressive code. Let's look at a list comprehension with a lambda function example. Given a list of numbers from 1 to 5, you can create a list of squares using a lambda function. The square function is defined as lambda x colon x to the power of 2. Then, a list comprehension uses this lambda function to generate a list of squares for each number in the original list. Also, you can add conditional logic such as creating a list of only the even squares from the original list. List comprehensions and the lambda function both have the common goal of creating output from input. Also, note how the list of squares is 1, 4, 9, 16, and 25, and the list of even squares is 4 and 16. Another approach is to use the map function with lambda to calculate cubes. Alternatively, a list comprehension can also accomplish this. Sometimes a combined technique where a lambda function encapsulates complex logic used within the list comprehension may be the most appropriate approach. Use map and lambda when working with multiple iterables. Use list comprehension for simple transformations. Combine them when logic is complex and reusable. Now let's cover some best practices and limitations to keep in mind when working with lambda functions. Best practices include: keep lambda functions simple and focused on a single operation. Use lambda for small, throwaway functions that you'll only use once, such as when sorting a list of students by their grade. Use descriptive variable names even in short lambdas. Consider named functions for complex operations or reused logic. Use lambda with higher order functions like map, filter, and reduce. Keep in mind these limitations. Lambda functions are limited to a single expression, meaning you cannot have multiple statements. There are no type annotations possible. For example, this is not valid in a lambda, lambda x : integer x, if instance x, string else x. There are no docstrings or built-in documentation. They can reduce readability when overused or when logic is complex, and they are not suitable for exception handling like try-except blocks. In summary, lambda functions are anonymous, single-expression functions defined with the lambda keyword, using the syntax lambda arguments : expression. They're commonly used as arguments to higher-order functions, for short one-time operations, and with map, filter, reduce, and sorted. The advantages of lambda functions include concise, readable code, inline function definitions, functional programming style, and reduced code complexity. Use them for simple operations, single-use functions, function arguments, and when readability improves. Thank you. Any questions? If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.